Hi, my name is John and this is Business Focus. In today's video, we'll be talking about what multicollinearity is all about, how to recognize if multicollinearity exists, and how to fix them. So let's get started. And we're back. Thank you again for joining me today. So in today's video, we'll be discussing what multicollinearity is all about, how to recognize if one exists, and how to or when to address multicollinearity and what in what particular method here. So I'll illustrate in a little bit an example here. So first and foremost, when you're dealing with multicollinearity, typically in statistical analysis, we're trying to find relationships with different variables here. In particular, typically the relationship between your independent and dependent variable here. That's what the norms in statistical analysis is trying to find whether there is strong or weak relationship versus if there's a significant relationship or no significant relationship between said variables here. Multicollinearity exists when independent variables have strong correlation or highly correlated. What I mean, so in its essence, when you say independent variable, that it can stand on its own, but when they're highly correlated, meaning they have a strong relationship, well, that's not necessarily independent variable anymore, right? So let's say the r or the r value or your correlation value is 0.7, 0.8, or 0.9 between two independent variables. The issue rises is you don't know which of those independent variables significantly impact or have a direct link, or is it a good predictor towards your dependent variable, meaning you don't know which one is the better predictor. Also, it reduces the accuracy or precision of your prediction here in terms of finding the best predictor, best model here. So how would you address this? So obviously, you need to be able to recognize multicollinearity exists. Now, you can use descriptive analysis by using correlation to look first if there's any values or variables you need to take a look at closely. And if you want to probe further, investigate further, then you have to ask yourselves, is there severe multicollinearity? Does it exist? Before trying to address it. Now, how would you recognize if there's severe multicollinearity? By identifying the VIF or the variance inflation factors, if it's severe. Now, there are three categories in VIF to remember. If the value of your VIF is equals to 1, there is no multicollinearity. You're good. Second category is if the value of your VIF is between 1 and 5, there is moderate collinearity. Again, you're still good here. But on the third category, if the value of your VIF is 5 above 5, whether it's 5.1, 6, 10, 20, and even beyond that, then it's considered severe multicollinearity. So you have to address that part. So typically, you may have to omit that variable, remove it to be able to address it. Now, another instance is it one of your main experimental variables here? Since if it's a control variable, not necessarily necessary to deal with multicollinearity there. So you have to bear that in mind. And lastly, is your purpose of creating this using these variables, is it for predicting your dependent variable here? If it's for prediction, for forecasting purposes, then the coefficients and the p-values here are not critical in this situation, so you don't have to deal with multicollinearity. But on the other hand, if you're using it for testing for significant relationship, then you have to address this, as mentioned, if there's severe multicollinearity. Now, how do we solve for multicollinearity? I'll show you in an example here. So let's take a look at an example data set here. So we can see here that we have 4 variables here from risk, pressure, age, and smoker here. So we have roughly around 30 sample size of data here. So to quickly identify if we need to So we can recognize if there's multicollinearity is by using correlation here. So let's go to correlation. Select all variables. Make sure it's grouped by columns. Check the box for labels, and let's display on the same page. Okay. So typically, when analyzing the correlation values here, typically we're interested in the relationship between your independent variable and your dependent variable here. In this aspect, risk is your dependent variable. Risk of a heart attack versus your independent variable, whether it's blood pressure, your age, or if you're a smoker or not here. So you can see here the relationship varies here. And then, you can test for regression, which is the best predictor here. But let's look at if there's any issues that we need to concern with, in particular multicollinearity. So we're looking at the the relationship between the variable pressure and age. So it's 0.32. So it's somewhat negative and weak relationship. You could argue if it's moderate. And then pressure and smoker is weak to, or very weak to, negative relationship. So that's not a problem. But age and smoker, slightly closer to moderate, but it's still, you could debate if it's weak or moderate and negative relationship here. Let's assume that age and smoker, you're you're noting this, that there may be multicollinearity here. So what do we do here? So as mentioned earlier, we need to test for the VIF here and find out if they're significant, if they're highly correlated here, if the value is more than 5 here. So how would we solve this? Now, obviously, if you have SPSS, it would solve it for you and identify if they have if they're highly correlated or they have multicollinearity here. But for the rest of us mere mortals here, so you can solve the VIF, which is very simple. You just solve it by dividing 1 divided by 1 minus the r square here. And how do you solve for the r square? Well, by using regression here. So let's create a table here. So variable, and then solve for the r square, and then the VIF, and then what's our interpretation. Okay, let's table. Okay. So let's r square superscript. Okay. So our 3 main variables here is you have pressure, age, and smoker. So we're thinking that age and smoking is highly correlated. So we'll try to solve for the VIF here. See if it's indeed has a severe correlation here. So let's test it. So when you're doing regression here, so obviously we're not going to use our dependent variable here. So for VIF purposes, to determine the r square, so we'll use regression. In this case, we'll use the variable that we think is highly correlated to be used as your dependent variable here. So in this case, let's start with pressure here. So pressure is one of your independent variables, but we're trying to find out if it indeed is highly correlated or not. Okay. And then for our independent variable, so we'll use age and smoker as your independent variable. Then check the box for labels. So let's display it on the side. Okay. So here we have our r square here. So let's copy the value. Okay, so it's 0.14. So let's adjust the value. Okay, and then let's do the same for age and smoker here. So if we're going to do that, let's move it around. Okay, then let's redo the regression model. So in this case, our dependent variable is age, in this case. And then our independent variable is pressure and smoker in this instance. Then let's display it on the same worksheet. Okay, in this case, the r square is 0.303. Okay, and then let's do it again. In this case, smoker will be your dependent variable. And let's see what the outcome is. So in this case, it's 0.22. So once you have your R square, you can now compute for your VIF. So as mentioned, it's just using the formula 1 divided by 1 minus your R square. And voila. It's 1.16, 1.43, and 1.28. So what does this all mean? So in this case, your VIF is considered moderate multicollinearity. So we don't have an issue here. So based on our observation, they have weak to moderate relationship. So even if you suspect that they have multicollinearity, by testing for the VIF, we have confirmed that smoking and age is not highly correlated to one another. So we're good. So the main question you need to answer is, what is our best model here? Now, I already went ahead and solved using forwards regression, or you could use any of the others, backwards, or even stepwise selection, and found out that that the best predictor is, let's go back, is pressure and age. Okay, with an R value of 0.65 and the P value is less than 0.05. So meaning pressure and age is significantly related towards a risk of having a stroke, and it is the best predictor to predict if you're going to incur a heart attack, if based on your blood pressure and your age here, which just was interesting. Smoker is not, even though it's not highly correlated or highly multicollinear, or not multicollinear, smoker is not considered a significant factor here. And let's assume here, what if pressure is severely correlated? So instead of 1.17, it's 5.17, right? So the issue that you have here, that it's we have to address this, right? And how would you address if your variable pressure has collinearity tendencies here, as you can see here? So what you do here is you remove the variable here. If it's if it's an experimental variable that you need for your study, and if it's for prediction, you can just ignore it, as mentioned earlier. And then if you're using it as a control variable rather than experimental variable, then you're still good. You can ignore it or not worry about it. And thirdly, as mentioned, if it's not severe, if it's only moderately multicollinear, then you're still good. But in this case, if it's severe enough, then you have to address it either by removing that variable, which would leave you with age and smoking as your only option here. But obviously, in reality, the data has already confirmed that pressure is not highly correlated with other independent variables here, as well as age and even smoking. So this is how we address collinearity in this scenario here, and it's very helpful. Obviously, somewhat tricky if you're not familiar on how to use this. That's why I'm showing this video for everyone to better understand, and hopefully apply it in their studies and in their research as well here. Anyway, that concludes our video for today. If you find this video helpful, Don't forget to hit the like and subscribe button to help continue grow this channel. If you have any questions, you can always leave your comments down below and I'll try to get back to you. Also, you can check out my other videos for more guides, tutorials, and tips. Stay tuned here always at Business Focus. As always, I'll see you in the next one. Take care.